Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to embark a new topic which is on parameters. Okay, in fact, there are several parameters. For example, for this video, I'm going to discuss on Z parameters. Besides Z parameters, we also have Y parameters, T parameters, S parameters, or ABCD parameters. Okay, so again, like what I mentioned for this video, I'm going to kick start on the Z parameters. As for now, let's concentrate just on two-port network. This will be the first series discussion on the parameters. The rest of the parameters, okay, once they are ready, for example, the Y, the T, the S, the A, B, C, D parameters, okay, I will put the video link under the description. So please take a look on those videos if you're keen to know more about parameters. This is my email. If you have any question regards on today's discussion, please drop me an email. Before I continue, I'd like to urge you guys to support this channel by pressing the like and also subscribe button. Please also turn on your notification bell in order to receive more information from this channel. Guys, please again, feel free to comment so that I know which topic that you guys are keen so that it will improve the quality of this channel. Once again, sincere thanks for your strong support. Thank you so much. Let's start by understanding what is Z or impedance parameters. A Z parameters metric describes the behavior of any linear electrical network that can be regarded as a black box with a numbers of ports. Okay, let's take a look on these two diagrams. On your left will be the one-port network, while on your right will be a two-port network. Okay, so this is what it means. Okay, so this little box here, we can actually regard them as black box, as mentioned here. So this will be a black box. Okay, so this Z parameters is actually used to describe the behavior of this one-port network, or it can also be used to describe the behavior of this two-port network. Okay, so this is what it means. It can be one port, two port, three port, four port, etc. Okay, knowing the Z parameters of a network enable us to treat it as a black box when embedded within a larger network. Okay, so what happened here is basically you can imagine that this two-port network actually cascade into more larger network. So these Z parameters can clearly just describe this two-port network, okay, without consider the rest of the larger network. But overall, when you actually form this larger network, okay, this Z parameters of this two-port network can actually be very useful to understand the characteristics. The Z parameters is also called impedance parameters or open circuit parameters, and the SI unit is ohms. Z parameters is members of a family of similar parameters such as S parameters, which I believe that you guys are very familiar, and also Y parameters, H parameters, T parameters, or ABCD parameters. Okay, so these few parameters will be the series of discussion under the topics of parameters. The Z parameters matrix of a two-port model is of order 2 times 2. Okay, so when we actually have two port, okay, the matrix is actually 2 by 2, as you can see from here. So this is 2 by 2 matrix. Any linear circuit can be represented as a two-port network with Z parameters defined by 4 variables: V1, V2, I1, and I2. You can see over here, these are all the Z parameters. You can see that basically they are defined by 4 variables: V1, V2, I1, and I2. Out of these 4 quantities, the I1 and I2 are independent variables. Okay, so this I1 and I2, they are independent variables, okay, which means that they don't actually depend on other variables. But for V1 and V2, they are actually a dependable variables because this V1 and V2 actually depend on I1 and also I2. So therefore, this V1 and V2 are called dependent variables. Z parameters metric describe the voltage current relationship. Okay, over here you can see that basically this Z is actually to describe the voltage in the so-called in a form of I1 and I2. So this is what it means here. In a two-port impedance network, it can be described by applying current to one port and determine the resulting voltage at all the ports, while the undriven ports are terminated into open circuit. Okay, so this is what it means here. Okay, for example, okay, we can actually determine, okay, these set parameters by applying current, for example, to I1, okay, and the rest of the port, basically, I will terminate as an open circuit. Okay, so later on, we will take a closer look on this definition. I think that will be much more easier to understand. Okay, so this Z11 is actually known as open circuit input impedance. Z12 is actually called open circuit impedance from port 1 to port 2. As for Z21, basically it's called an open circuit impedance from port 2 to port 1. And Z22 is actually called open circuit output impedance. Okay, the condition of reciprocal or symmetric exists in a system can be easily identified from the Z parameters. Okay, the condition for symmetric will be Z11 equals to Z22. And the condition for reciprocal is Z12 is equals to Z21. Okay, so this is just a very quick discussion on Z parameters. Okay, so this is the diagram of a two-port network, which I have shown it to you earlier on. So these are the two equations here. So how to find Z11, okay, is basically governed by this equation. When I actually want to find my Z11, okay, I need to let my I2 is equals to 0. Okay, which means that this is equals to 0. This term actually disappeared. So therefore, my Z11 is actually equals to V1 over I1, as I actually obtain from here. Can you visualize here? So how to get my Z11 again? Okay, so I need to get my I2 is equals to 0. So once this is equals to 0, this whole term becomes 0. So in order to get Z11, okay, I need to do V1 over I1, which is shown over here. Same for this Z12. Okay, how can I get my Z12? My I1 need to be equals to 0. So this term actually disappeared. So how to find my Z12? Okay, will be V1 over I2 in order to find my Z12. Next, how to find my Z21? Okay, which is here, and my I2 is equal to 0. So once my I2 is equal to 0, this whole thing becomes 0. So in order to find my Z21 will be V2 over I1, which is illustrated here. Last but not least, on Z22, how can I actually find my Z22? The condition must be I1 is equal to 0. So this thing becomes 0. So therefore, to find my Z22 is actually V2 divided by I2, which is illustrated here. Okay, let's take a look on an example in order to understand this better. Okay, so in fact, this example is from POSA book, okay, but I have somehow used another method which I think will be much more easier to understand. Okay, I'm not saying that idea from POSA book is not that clear, but I'll just make it very simple, just in case that those who are looking at this video are so-called the beginner. Okay, so let's do this example in order to understand Z parameters or impedance parameters. Find the Z parameters of the two-port T network shown below. Okay, so this is the two-port T network. So this is the first port. This is the second port. I have this V1. I have this V2. I have I1 here and I2 here, which I will show it to you later on. These are all the terms that I've described on the previous page here. So I will skip for this part here. Okay, so let's start by examining this Z11. How can I actually get this Z11? And remember Z11, earlier on, I have done this from here. Okay, so I put it here. So my I2 is equal to 0. Okay, which means that I don't have any flow of I2. Okay, so once I do not have any flow of I2, I can assume that I1 flow here, and they actually also flow into ZC, right? So basically, I1 flows ZA and also to ZC. Okay, how can I actually obtain my V1? Okay, my V1 is actually the voltage from here to here. So it's actually equals to I1, and the two resistors ZA and ZC, they are connected in series. So which is I1 multiplied by ZA plus ZC, which I will be able to obtain my voltage V1, correct? So therefore from here, I cancel away my I1. So therefore my Z11, I actually can obtain, which is ZA plus ZC, correct? So much more easier. So let's do Z12 now. So how can I actually do this Z12? Okay, again, this actually just discussed earlier on. So basically now the I1 need to be equal to 0. So this must be equal to 0. So therefore I only have I2 current that flowing. So I2 current that flow this part here, and finally to this part here. So how to find my V1? Okay, my V1 is actually, since there are nothing flow over here, okay, so therefore I only have current flow over here, which is the current of I2. So my V1 is equal to I2 ZC. Do you agree? So therefore from here, I find my Z12, which is equal to ZC. Because this I2 I cancel away. Okay, remember this V1 here, okay, there's nothing drop because this is zero current. Okay, so basically over here, the current I2 flow, okay, I assume that they will flow this part here. Okay, so therefore my V1 is actually equal to I2 ZC, which is illustrated here. So this I2 I cancel, I actually get my ZC. So my Z12 is equal to ZC. Next, let's find my Z21. For this case will be V2 over I1 while I2 is equal to 0. Okay, which means that there's no current flow here. Okay, I only have current I1 flow. So basically current I1 flow through ZA and also flow through ZC. Okay, how to find my V2 again? So basically, as I told you here, this V2 is actually equal to I1 multiplied by ZC. So again, it's the same thing as what is happened on Z12. Okay, this I1 I cancel. So therefore, Z21 is ZC. Okay, you realize that this is actually so-called a reciprocal. Earlier on, I had mentioned that Z12 is equal to Z21, which is also called a reciprocal. Okay, so last but not least, let's quickly do this. Let's find this Z22 here. Okay, so this Z22 here basically governed by this equation, which is V2 over I2, and the current I1 is equal to 0. Okay, which means that I don't have a current I1. I only have a current of I2 flowing through ZB and ZC. And they are all connected in series. Can you see here, ZB and ZC, they are connected in series. So how to find my V2 is actually equals to I2, okay, multiplied by ZB plus ZC, which is illustrated here. Okay, again, I can cancel away my I2, which happen to get my Z22 is equal to ZB plus ZC. Okay, so this is how we can easily find the Z parameters. Okay, I put all the thing into one slide here. So this is the question. These are the two equations that I mentioned to you. So how to fill up my Z parameters? Okay, if you still remember Z11, I actually found it earlier on. Okay, so Z11 is here. So it's equal to ZA plus ZC. Okay, so therefore I'm going to put this ZA plus ZC. Z12 and Z21, they are actually ZC, if you still remember. As for Z22, okay, basically they are ZB plus ZC, okay, which is illustrated here. Okay, again, you can also modify this matrix here. Okay, so you can see that this is ZA plus ZC, ZC, and ZB plus ZC. Okay, so this is actually how we can actually obtain the Z or impedance parameters. This is just only on two-port network. Okay, I just want to quickly to discuss about multiple network. Okay, so this is for multiple network. Okay, so you can see this is basically with more than two ports of networks. Okay, so basically you can see that this matrix is all the way to N. Okay, you can see from this diagram here, this is a multiple ports network. Okay, so with this, I'd like to end my discussion. Please help to like and subscribe. Once again, sincere thanks for your strong support. See you guys. Thank you so much.